All right, so you're going to be doing the Law of Conservation of Mass lab, and basically you are observing a chemical reaction taking place, and you're going to answer some questions related to your observations. And you want to read the introduction, which is only a couple of lines, to the lab, and you want to memorize the word equation, and you want to memorize the chemical equation. Okay, those are right here in the introduction portion. Okay, then the procedures are divided up into 3 different trials. You need to wear goggles the entire time, and you need to wash your hands when you're done. And for trial 1, you're taking an empty beaker and you're putting some vinegar into the beaker, okay? And you're going to get the mass of the empty beaker, the mass of the beaker, and the vinegar. Make sure that you don't get the electronic scale wet, and if you do, I need you to wipe it off, okay? You're going to weigh out about 5 grams of baking soda to place into the beaker with the vinegar, and it asks you to use weighing paper when you are measuring out the baking soda. So up until this point, you guys aren't very familiar with weighing paper, so let me just explain for a second. You can use a regular piece of paper. You could use a piece of printer paper. I'm going to have some paper in your green tubs to help you along with it, but long story short, when you have a piece of paper and you're going to weigh something in it, you want to fold it up like this. So I folded this up twice. Okay, I folded it once halfway, and then I folded it again. And so now it's in 4s like this, okay? Because when you put it onto your electronic scale, the solid that you're weighing out is going to rest in the middle, and then it's easier for you to pour it out, okay? So this is just an example of what to do with weighing paper. So you're going to have the beaker open to the environment for trial 1 with the baking soda and the vinegar reacting in it. I have clearly labeled in the data table how to do the math with letters, okay? So you need to pay attention to that, and make sure when you're adding and subtracting, you're following significant figures. So make sure you're drawing the line, you're lining up your decimals, and you're writing all the digits to the left of the line. Okay, now for trial number 2, what you're going to do is you're going to have an empty 2-liter bottle, which looks like this, and you're going to be putting vinegar into it, and you want to try to avoid getting this part. So you're going to have a funnel that you put in here, and you want to try to avoid getting this part wet, because when you go to add your baking soda, the baking soda is going to stick to that part. So make sure you're using a funnel, and you're going to do the same thing here. You're going to add the baking soda in, it's going to react with the vinegar, and you want to keep the cap tight on, so that way it's closed to the environment and the reaction is taking place inside this container. Okay, follow the directions, and again, I've given you a table here to report all of the data, and your calculations are really straightforward. Okay, now when you turn the page for trial number 3, I've given you a picture of what it is that you're doing and what it's going to look like. You're going to have a flask, and you're going to be putting vinegar into here, and you're going to use the funnel again to get the vinegar in. You're not going to get the neck, which is this part, wet, okay, because if you did that, then it would be harder for you to add the baking soda solid into it, okay? So then you're going to be putting baking soda into it, and you're going to be putting baking soda into a balloon, and then you put the balloon over the neck portion, the opening of the Erlenmeyer flask. Okay, so essentially this would be another example of a closed container where you have the reaction taking place inside of it, and the balloon should inflate as the gas is produced. All right, so again, you're going to be recording all of your masses here in this data table and doing some really straightforward calculations. At the bottom, I've asked you to do some percent error calculations, and I tell you how to do it. It's totally straightforward. Watch your sig figs on the subtraction stuff. That's the only place that you could possibly really go wrong. Remember that the number 100 is exact because it's a part of the equation before you put your numbers into it. That means it doesn't affect sig figs. Then you have some questions on the back that you have to answer. These are some critical thinking questions. Okay. For indicating the states of matter for each reactant and product here in number 3. Remember that in the beginning of chapter 4, I talked about solids, liquids, and gases, and I abbreviated solids with an S, liquids with an L, gases with a G. When solid substances are dissolved in water, like when you have a salt dissolved in water, it has a little AQ after it. Okay, AQ means aqueous, and it stands for dissolved in water. And that's it. Everything is really simple for this lab, and I think you'll enjoy it.